are watching Darasa Online.
Hello, welcome to Darasa Online. My name is Mwalimu Kileo Davidson Abubakar. I'm a geography teacher. Today we are going to see soil formation as well as soil classification based on our main topic of soil or study of soil, or sometimes we call it soil geography. So let us see some concept regarding soil. You know, soil is wide, it's comprehensive, and it has it got some divisions, very small division, which you as a student, you have to make sure you have covered almost all of them. Because remember, in your exams and most of the either mock exams, nectar exams, they've never, you see, left the question which are from soil, or so question regarding soil. Why I say that? Because we've seen 99% of the nectar question, more questions, they have that question. So let us see what is soil by definition. I want to make a clear history of where do soil come from. See, what is soil, where soil have come from. We all know what is rock. Rock refers to the solid part of the Earth's crust. Inside the rocks we have mineral, we have different elements. So when rock undergo weathering, it means it may disintegrate into smallest particles. See? So the smallest particles, after the disintegration of rock, we call them regolith. The accumulation of those particles in a certain place, once they stay there for a long period of time, they may undergo as a simple and complex process to form what we call it soil. So soil will refer to the body of system which is a result of many combinations. Are we together? That's why, that's not the definition of soil. I'm talking about the history of soil. That is, soil has history, and it comes from far away. That at the beginning we have what we call the parent rock. We have a rock. This is our rock. Let us assume this is our rock. See, a rock. This one. This is what we call the parent rock. So the parent rock has to undergo what we call weathering. Weathering, then it forms small, it disintegrates into smallest particles. This one. Then the accumulation of these particles together, we call them regolith. Regolith, this one. So regolith, it's not a soil. See? Regolith are the accumulation of different soil particles or rock particles. Right now, this regolith has to undergo further processes. We call them simple and complex processes of soil formation, where later, after staying for many years, you see, it's where it forms what we today call it soil. So soil, it got history, as you can see right here. So before soil, there was what we call the parent rock. Then the parent rock undergo disintegration through weathering and the other agent of erosion. It formed what we call regolith. Then a regolith has to undergo further simple and complex processes to form what we call it soil. So what is a soil? Then we say soil refers to the very thin layers of the Earth's crust, which found at the uppermost part, where it's made up of organic and inorganic materials. It means right now, after the disintegration of this regolith, during when we say soil, it undergoes simple and further complex process to form soil. It means right now we have different, for instance, living organism remains. They added it to this what we call regolith, and then they may form other part of the soil. That's why you say after soil undergoing different processes, simple and complex process, it may take time, see, before it become, or it is known as what? As soil. So in taking time, it means there are addition of different material. See, we have the living organism material from its rock, regarding including mineral and element, etc. We have air, we have water. All of those material have to be added into the soil to make it soil clear. You see, that's why soil refer to the what? Refer to the thin layer of the what? of the uppermost part of the S2 crust made up of organic and inorganic material. We are at the end, it can support the life, or it supports the life of living organisms, both plants and animal. Okay, that is the a simple history of the soil and the definition of the soil. So from there, there are some simple questions, or some questions sometimes may be asked: why soil is considered as a living entity? Why do we consider the soil as what? As living things. We consider soil as living entity or living things because it has the characteristics similar to living things. See? So let's see why soil is considered as what? As living things. Why soil is sometimes considered as living things. So we consider soil sometimes as living things due to the following reason. The first reason is, remember, soil is made up from parent rock. Soil is considered as living entity. Why? Why soil is considered as living entity? It means we have reason here. Why soil is considered as living it, we have a lot of reasons. So the first reason is soil originated from parent rock. Originated from parent rock. The mother rock, which gives the nature plus the origin of the soil, similar to living things. Origin of the soil. As you can see today, maybe why this soil is red, it means it is red because the parent rock which has been disintegrated to form soil, it is red in color. Why is this soil is maybe white in color? It is white in color because the parent rock which have been disintegrated to form the soil, it is whitish in color. For instance, the calcium carbonate rocks. Why this soil is called a sandy soil? It is called a sandy soil because it has originated from the sandstone. Are we together? So soil is made up of parent rock, or the mother rock, is similar as it what? To living organism. Then from there, we say soil can be created and destroyed through, soil can be created and destroyed through bad method of farming, for instance, etc. So similar to living organism, as you can see, similar to living entity. Living entity can be born and die. Are we together? So soil is created. How do soil be created? Or how can the soil be created? Or it created from where? We know it created from the parent rock. How do soil created? It created through weathering. Then it undergoes simple and complex processes to form what we call soil. So similar to living organism. Organism can be born and die at the end. So soil also can be created and destroyed. We have seen different bad methods of farming, for instance, which can destroy the soil, from good soil to poor soil, to unproductive soil. This is another point. Then we say soil, it passes different, processes, where we are talking about simple and the complex process in its formation. You see, soil, it got history, and it comes from simple to complex processes. So because soil, it passes process from one process to another process, it means in this way it is similar to living organism. We know living organism, we come from simple process to the complex one. See, from the beginning to where someone can call you a man. See, so you started from the initial point to where you are today. So it is similar to soil. Soil, it is created from what? From the parent rock, and it passes processes, simple process to complex process, similar to living organism. We all know what are those processes. The first process is what we call the weathering. Then the second process is what we call the eluviation. We come to eluviation. We go to what we call the calcification, humidification, etc., etc. Then we have those complex processes, including the polarization, the lateralization, glaciation, etc. So it is similar to what? To living organism. Why? Because it passes different processes. As it passes different processes, then it undergoes times. You see? It undergoes time in what? In its formation. Similar to living entity. As the living entity grows from small to the large one, or from small to the big one, you can see it undergo what? It undergo time, which it take a very few time to the longer the time. So the longer the time the soil takes, it means the more mature it becomes, similar to the living entity. The few times, the longer the larger the time the living entity takes, the mature the living things will be. So similar to soil. Then from there, we say soil, it is made up of soily water. See? It is made up of soil water, similar to living things. We know soil, it is made up of soil water, where 25% of its body is made up of water. 25% is made up of water. Where do water come from? The soil water come from? It means the soil water comes from either rainfall, see? Either from rivers, see? From lakes, seas, and what? And the oceans. Similar to living organisms. The good point is that living organism, it's made up of 75% of its body is water. So right here, 25% of it is what? It's water. Then we have air. See? It's made up of air. It is made up of what we call soil what? Soil air. Similar to living organism. Soil, it needs air for it to be more productive. We need air for us to be active and to survive. So at this point, where do soil air come from? It means from the atmosphere, see, or from the living organism found inside the soil. Living organism, living organism found inside the what? Inside the soil. Inside the soil. So soil is made up, another characteristic is that soil is made up of soil temperature, similar to living organism. We have living organisms which are called blood temperature and this warm blood temperature. We all know that. We have the, so similar to, to soil, we have soil which is found in a polar area, which is cool in its temperature, and we have soil found in tropical areas. The soil found in tropical area is warm, in terms of temperature. Thank you very much. Okay, student, we have seen some of the characteristics or the criteria that said that sometimes soil is considered as a living entity discussed. So if you have come across that question, it means you have to answer the way I've explained earlier. So let's go to some of the competence questions, especially in soil geography. So we have the model question right here based on the study of soil. It says that the agriculture officers from 5 districts of southern region of Tanzania were gathered in a meeting so as to discuss how to improve crop yields in their district. One of them pointed out that they first have to know the type of soil in each district. Describe 8 criteria that will be used to classify soil. So you have to stick there. It means we have agriculture officers from 5 districts. Right now they have to make sure they increase the crop yields within their district. So the point is, one of them said that in order to increase the crop production within their district, they have to firstly check on the type of soil in each district. So the point is, how are you going to know this type of soil can be good for for agricultural activity so that they can yield more and more crops, so that they may yield more and more crops. That's why the question said, describe 8 criteria that will be used to classify the soil. So the need of the question is, we have to mention or to explain 8 criteria that may be used to classify the soil. So as you remember, in soil classification system is cumbersome. Why? Because it involves a lot of criteria. And sometimes you may find most of the geographers, for instance, they classify soil firstly, I mean, in those early years, many years ago, they have classified soil according to different groups. Some of them, they were classifying soil according to order, you see, suborder, groups. Some of them classified soil according to great groups. Some they have classified soil according to what you call family, series, etc., etc. Today we will stick on what we call classification of soil based on order, where right here we have 3 types of soil. See, we have what we call the zonal soil order, zonal soil. We have the intrazonal soil order, as well as the azonal soil order. And the other characteristic, we have left it behind. Why? Because as I've said earlier, that the classification of soil is cumbersome. It's difficult to classify soil because soil is is made up of different entities, and within it can be classified or grouped into many subdivisions. So apart from that, in a basic way or in a basic concept, you can classify soil according to 3 groups. We have the matured soil, we call it zonal soil order. We have the intrazonal soil order. It means the matured but have lacked some condition to be pure matured. And then we have the azonal soil order, or the immature soil. So from there, these are not the criteria that have been used. These are a system of classifying what? Classify soil. So let's see the criteria that they may use to classify soil. So at the end, they will get the increase in production within their districts. So one among the criteria that they may use in classifying the soil is what we call soil depth. See? Criteria used in classifying the soil as the question need. It means the question need us to explain different criteria that may be used to classify soil. So listen to me very careful. The criteria that may be used to classify soil can be defined by the soil properties that can be measured quantitatively. Are we together? The criteria that may be used to classify the soil are those criteria that can be defined by the properties of the soil that can be measured quantitatively. That's why I say criteria used in classifying soil. It means right now we are talking about those criteria that can be can be defined by property and measured in quantitatively form. Quantitatively what? Form. And one among the criteria is soil depth. Soil depth. So what is soil depth? Soil depth will refer to either the shallowness or the deepness of the soil depth. The shallowness or the deepness of the soil depth will refer to the soil depth. It means sometimes we may find soil which are found in steep slope. Those which are found in steep slopes are shallow in depth, while those found in gentle slopes, they are deep in depth. Let me draw right here. It means, let's assume this is steep slope, this is gentle slope. See, this is steep slope, this is gentle slope. It means we have soil which are found in steep slope. Soil which are found right here and right here. This is steep slopes. This one is gentle slope. So how deep the slope of the soil is what we call the soil depth. It means, as you can see right here, the depth of the soil is shallow, while right here, the depth of the soil is deep. So the deepness or the shallowness of the soil slope, we call it what? The soil depth. So we can classify the soil, we can use this one as the first criteria. Why? Because remember, soil found in steep slopes, because it is shallow in its depth, then it is poor in productivity. While soil found in gentle slope, because it has a deep depth, then this one is good soil. This is the first criteria. Then the second the second criteria is soil temperature. Soil temperature will refer to the coldness or hotness of the soil body in terms of temperature. When you say temperature, it means you are talking about the coldness or the hotness of climatic condition of a given area. So in terms of soil, when you say soil temperature, it means you are talking about the hotness or the coldness of the soil body. So we remember earlier I said soil which are found in polar area, they are cool or cold in temperature, while those found in the tropics area, they are warm or hot soil body. So the point is, most of the soil which are found in hot climate, in terms of temperature, are more productive soil compared to the soil found in polar or pool area. Why? Because one among the criteria that may be used to determine the productivity or the growing of a seed within the soil is temperature. We expect the warm temperature rather than the cold temperature for a plant or a seed to grow. This is another criteria. Then we go, let's see another criteria, which is another criteria for classifying the soil. Another criteria for classifying the soil is, the third one is soil texture. Soil texture will refer to the fineness or coarseness of the soil particles. It means the smallness or the largeness of the soil particles will refer to the soil texture. So we can classify soil texture according to 3 or 4 types. It means we have types of soil according to texture. So types of soil according to texture, we have what we call the clay soil. Then we have the sandy soil. Then we have the silty soil. Then we have the loam. Clay soil, it is a soil texture with a very fine particles, followed by sand, silt, and loam. And remember, the loam soil, it's the combination of the three. The loam soil. This, if you take clay plus sand soil plus silty soil, it means you get the loam the loam soil texture. So in this type or in this category, you can be able to classify which soil will be more productive than the other. It means we say it depends on the characteristics of the soil texture. Most of the time we found clay can be more productive when improved. When you use manure in clay soil, it means the soil will be more productive than the other. When you come to sand and silty, it depends on where they are found. It means most of the sand soil, for instance, they are poor in retention capacity, but they can hold the amount of water not for much longer time. So in this point, most of the sandy soil can be poor in terms of productivity. Why? Because they tend to lose water in a very fast way compared to loam or clay. Then from there, by using the soil texture, it means the officers, they can know which type of soil they may be supposed to use so that they can increase the crop production in their district. Then they have to see the soil texture and their properties. Then from there we have soil structure. Soil structure will refer to the arrangement of the soil particles which form a definite pattern of the soil grains within the soil body. Soil structure, it forms or refers to the definite pattern. The definite pattern of the soil arrangement. Soil arrangement within the soil body. Within the soil body. See? So in a simple way, I can say soil structure will refer to the arrangement of the soil grains or soil particle within the soil body, which give a certain shape of the soil particles arrangement within it. So my point is we have different type of soil structure. We have different type of soil structure. We have what we call the plate-like structure. We have the plate-like structure. We have the cramby-like structure. We have the spherical soil-like structure. We have the what we call the prismatic soil-like structure. We have the columnar soil-like structure. We have the blocky-like structure, etc. So these are the soil structures that may be found within the soil body. So the point is, in order for the soil to be productive, it depends on what? So the point is, from there, how are you going to determine this soil is more productive? You determine this soil is more productive according to its structure based on its function. See? So you see the general function of the soil structure. The general function of the soil structure, first, soil structure can help in water retention capacity. Are we together? It can help in what we call the fertility improvement through the use of artificial manure, for instance, fertilizers. Sometimes soil structure can determine the microbial activity within the soil. Soil structure may determine the soil moisture content within the soil. Soil structure may determine the mineralogical composition of the soil, as well as the eluviation and the calcification process within the soil body. So through the property of the soil structure or the function of the soil structure, it means one can be able to determine which soil is more productive than the other. Then from there, we have another criteria for classifying soil, which is another criteria for classifying soil. Another criteria for classifying soil is soil mineralogical composition. See, for soil to be more productive, it depends on the amount of minerals the soil composes. We say the amount of minerals the soil composes, it depends, or it originated from the parent rock, from the parental rocks. So we said if the parent rock was made by many mineralogical composition, then we say the soil is made up of more mineral. So if it's more minerals, it means the soil will be more productive. Then we say mineralogical composition of the soil depends on where the soil has occurred. You see, either at the steep slope or at the gentle slope. At the steep slope right here, we have poor soil because there is fast flowing of water down a slope. So automatically all the material will be taken from the upper level or at the steep slope, and they'll be brought right here at the gentle slope. So it depends on the slope type. Mineralogical composition can be more at the gentle than at the steep slope. So most of the soil found in steep slopes, they have low mineralogical composition compared to this point. Also, it depends the agricultural activity. Agricultural activities carried out. See, example, it depends on the type of crops planted. You see, there are plants which when you plant them in a certain soil, they may improve the soil. See, and there are plants which once you plant them inside the soil, sometimes they may make the soil to be poor. Why? Because they do not improve the soil characteristic in terms of mineralogical composition. Then from there we have other human activities, for instance the use of manure, fertilizers, etc., etc. Then from there we have another criteria that may be used to classify soil. Okay, another criteria that may be used to classify soil so as to determine if it's more productive soil or less productive soil is soil organic matter content. We say the soil which is made up or is comprised or it's made up of more organic matter will likely to be more productive than the soil which it has less organic matter content. We all know that the organic matter content depends on the living organisms that they are found in that area. That's why I say most of the soil found in area which is bare land is likely to have less organic matter content compared to the soil found in areas with dense forests. For instance, along Amazon, there are equatorial areas, because most of the equatorial areas, they are made of big forest, etc., etc. So from there, I can conclude that soil organic matter, it's very important for crop production, okay, or for crop or soil productivity. Then from there, we have to we can see another factor right here. We have what we call the soil moisture content. Soil moisture content. When I say soil moisture content, it means I'm talking about the amount of moist air within the soil body. So remember, the soil which is pure dry is less productive than the soil which have more moisture content in terms of its productivity. Remember, for seed to germinate, it means it needs moisture. And for instance, the soil which are found in area of tropics during the wet, they can grow even if there is no rainfall. But soil which are found in area which is pure dry, for instance, in desert area, it's not easy for it to make crop production or crop productivity. That's why soil moisture content is very important in crop production. So this is another criteria which can be used to determine soil productivity. Then from there, I can take this as my last point, that we have what we call the cation exchange capacity. The cation exchange capacity. We know what is cation exchange. Cation exchange refers to the process whereby the metal ions which are have positive ion exchanges, they replace the hydrogen ion which are found inside the soil. So to this point, it means the soil right now is changed from acidic soil to alkaline soil. So at that point, it depends. Most of the material which are basic in nature, they may be they may be a result of the soil either to be productive or not. That's why you say cation exchange capacity. If the soil has more cation exchange rate, it means it may be either productive or not. Depend on what? On type of crops. Depend on the type of crops. Why I said this? Because there are some crops which grow well in acidic, and there are some crops which may grow well in basic or alkaline soil. So it depends on the cation exchange capacity. Some of the cation exchange elements may replace the hydrogen ion inside the soil and make the soil to be more alkaline than the previous time. Or if there will be less cation exchange capacity within the soil body, also the soil may remain acidic in nature. Why? Because to the presence of hydrogen ion inside the soil. So to that point, it means this point will be more acidic. So as I've said earlier, these are the criteria that may be used by the agriculture officer. Is the question needed or the question asked to explain whether which criteria will be used to classify soil and make it the soil more productive or not to be more productive. Okay, let's see another question which is based on what? On soil as study of soil as competent questions. Let's see another question. The relative influence of soil formation factors vary from place to place, and the combination of factors determines the kind of soil. Listen to me very carefully. The relative influence of soil formation factors. Soil formation what? factors vary from place to place, and the combination of factors determine kind of soil. Substantiate the statement with 5 points. So the key needs of the question right now, it needs us to explain factors for soil formation. Factor for soil formation as the determinant of the different kind of soil. So in my introduction, how are you going to answer the question? Introduction, you have to determine what you have to define what is, you'll explain what is soil. See? Then what is soil formation? Then from there, you'll go to the main body. Main body, you'll explain factors for soil what? For soil formation. You explain factors for soil formation. We know soil is a function of parent rock, climate, relief, organism, as well as time. So these are the 5 factors for soil formation. We need time, we need parent rock, climate, relief, organism, as well as time. So these are the factors for soil formation. So in explaining factor for soil formation as a Form 6 student, and remember right now we are making a revision, it's very important to know the roles or the function of each factors. In explaining factor for soil formation, you have to know the roles or the function of each factor. So let us start with the P, it means the parent rock. We have what we call the parent rock. See, parent rock refer to the soil, the rocks which give the origin of the soil. It owns the life cycle of the soil in general. So the roles of the parent rock, roles of the parental rocks. It helps to determine the mineralogical composition. Mineralogical composition. See? The nature of the minerals, the soil composed depend or it originated from the parent rock. Then color of the soil. It helps to determine the texture of the soil. It helps to determine the productivity of the soil. You see, soil porosity depend on the nature, how hardness or softness the parent rock is. This is the function or general function of the parent rock. Then we go to the second factor. The second factor is climate. Climate. It means right now, let us talk about temperature and what? And rainfall as a general factor for soil formation in terms of climate. It means right now, let us focus on temperature. It means temperature, it helps in the disintegration of the parent rock through repetition increase in temperature. It means during the day, the temperature expanded. During the day, it means there is an increase in temperature, the rocks expanded, the rocks mineral expand. During the night, it means there is contraction of the mineral of the rocks. So the repetition, contraction, and expansion may result to the breaking down of rock into smallest particles as a first process of soil formation. Then we go to rainfall. It means the presence of rainfall in a particular area may either influence the following. First, may influence the transfer of nutrients. Transfer of nutrients within the soil body. The disintegration of soil particles into more grains, into more fine grains, you see, into very smallest particles, depend on the rainfall. But it helps to determine the soil moisture content. Moisture content of the soil, it depends on the amount of rainfall of a particular area. But remember, rainfall determines the microbial activity inside the soil, microbial activity. Rainfall determines the soil water, amount of soil water inside the soil. It is determined by the presence of soil as climate of a given factor. So we say by concluding that most of the area with high moderate temperature and high rainfall, it tends to influence the formation of the soil by referring to these factors. Then from there, we have, let's see another factor. Let's see another factor is the question needed. We have what we call the relief. See? Relief or the topography. We know the relief of an area can influence the formation of soil in different ways. For instance, let's consider at the steep slopes and at the gentle slopes. At the steep slope and at the gentle slope. At the steep slope, we know the soil formed right here is poor soil, shallow. Poor soil is a shallow soil. So automatically at the steep slope, the soils that will be formed right here will be, we consider it to be unproductive. While at the gentle slope, the soils that will be formed right here will be the good soil, because it is thick soil, not the shallow soil. So soil formed at this point, it is what? It is good. Then from there, we can explain relief in other way, or on the, for instance, area receives sunshine at the windward side. See, most of this area, they are like to be more moisture. So at this point, there is more growth of plants, which determine the organic matter content of the soil, which makes the soil to be more productive. This is the good point. Then we have the we have another factor, which is organism. Organisms, they determine the first is the mineralogical composition of the soil, because at the end they may make the soil to be more productive in terms of its nutrients. And apart from that, the organism may help in the disintegration of soil into smallest particles. For instance, the organism found inside the soil. Apart from that, organism may influence the humification process, the decaying of their bodies into the soil. They make what they call the organic matter content in large amount. Then apart from that, organism may determine what we call the microbial activity inside the soil. Then from there, we have time as the last factor for soil formation. We say the longer the time the soil takes in its formation, the mature the soil it will be. The shorter the time the soil takes in its formation, the less the mature the soil will be. So in order for soil to be complete, it means it needs to take or to have more time in its formation. Then from there, I can conclude by saying these are the factors for soil formation. By giving it summary, it's better you understand the role of each factor in the process of soil formation, so that when you are explaining factor for soil formation, then you will be able to mention the function of each factor, as I mentioned, as I've tried to mention earlier. Right now, that here. From here, we can say this will be the end of our session for today. Welcome until the next session. Then I'm going to say, make sure you study soil, because soil, it always brings the question by 99% in either mock exams, in your normal school exams, or in NECTA exams.